Hello, this is Calculus AB 2016, problem number 6. It's a data table problem. This is actually a lot easier than normal. It's pretty straightforward. I think it's a nice problem, so let's do it part A. They give you k of x. That's given. It's a composition of functions. And they want the equation of the tangent line. I wonder where I've seen this before. Golly gee, I don't think I've ever seen this. I wish Mr. Yoshida would have taught us the equation of a tangent line. Okay, they wanted x equals 3. So my x1 is 3. To figure out my y1, I need to figure out what y is. But it's this function right here. That's my y. So k at 3 would be f of g at 3. Well, let's look for g of 3. Here's g, here's 3, it's 6. That's 6. So now I know my y1. Next, we need to know the derivative, because the derivative tells us the slope. So the slope will be k prime at 3, but we don't have k prime. So over here, or the derivative of k, we have a chain rule. It's f of box. What's the derivative of f of box? That's going to be f prime of box times the derivative of box, but derivative of g is just g prime of x. There is that. So k prime of 3 will be f prime of, box. Yoshida messed up. Back up. Let's do this all over again. Sorry, everybody. K prime of x. It's f prime of box times the derivative of box. So now let's go to this. So f prime of g of 3 times g prime of 3. Well, g of 3 is right there. That's 6. And g prime of 3 is 2. And f prime of 6 is right there. 5 times 2. So now I know my slope is 10. Plug everything in. And I am finished. Finito. There is my equation of my tangent line. I am done. You don't have to add the 6 to the other side. It's fine. We are good. Let's go to B. I like this problem. It's nice. It's nice. It's easy. So h prime of x, it's low. Wow, that's not low. It's low d high minus high d low all over low squared. H prime at 1 is f of 1, g prime at 1, minus g of 1, f prime at 1, over f of 1 squared. Let's plug everything in, and we're done. Isn't this beautiful? F of 1, let's do it in blue. F of 1 is negative 6. G prime at 1, g prime at 1 is 8. Minus g at 1, that's just 2. F prime at 1, that's 3. And f at 1 is negative 6. It's given. There is my answer. I am finished. That is all. You should never simplify it to this, but that is the simplified form. All right. Let's go to C. You see? Oh no. Now, 2 ways to find the value of a definite integral. It's the net area, or you have to do the fundamental theorem of calculus. I'm have to use the fundamental theorem, but that only works when I just have a single variable there. That is screaming U sub. So I am gonna find that. Do I have a 2x dx? Now I do. So du will go in for 2dx. Bam. And u will go in for 2x. And now we're on our way to good things. It's going to be f double prime u du, but here is where you need to be careful. This value here and that value there, those are x's. See, our variable's x, but here are variables u. We have to convert them to u's. So plug in 1 into this equation, and u comes out to be 2. Plug in 3 into this equation, u comes out to be 6. Nice, nice. What's the antiderivative f double prime? It's f prime. That's easy. Easy peasy. Then we plug in our values. We have f prime at 6 minus f prime at 2. And we look at our chart. F prime at 6 is 5. F prime at 2 is negative 2. Finished. Don't have to go any further. But if you are a fool, you might take it to that answer. All right, that's it. That was a pretty easy question in my eyes. All right, bye.